Hello, everyone, and good afternoon. Welcome to Mitigant and Technaura webinar. Today, I've been joined as well with Rahul Kumar, Senior Data Engineer at Technaura Systems GmbH, one of our partners at Mitigant. So, just to give a brief introduction of him as well. So, Rahul is a seasoned solution architect with over 12 years of industry, with a lot of experiences coming in from the retail, telecommunication, e-commerce, and pharmaceutical sectors. He also has a master's in computer application with expertise in solution and product architecture, with his proficiency actually in cutting-edge technologies such as Kafka, IoT or Internet of Things, AI, machine learning, and cybersecurity. So, without further ado, then I will hand over to Rahul to start the presentation. So, Rahul, over to you.
Yeah, thanks a lot, Isan, for the introduction, and let's get started on the topic what we are pointing out. So I'm sharing my screen, and this is actually we are going to discuss today about Kafka, machine learning, and what are the different threats we are encountering day to day, and what are the new challenges that we are coming. And we are taking a huge case of IoT, how this is getting connected with Kafka and machine learning, and how the real-time threat detection works here, and what are the security risk is there. So this is our agenda for the today's webinar, and we'll go in all the agenda item one by one. So I'll just give some brief about it. So this is first one. We'll just go through what is Kafka and what is machine learning, and about the some basic detail. And as we know that it's quite familiar to everybody, so I'll not go more in depth. Then what is the importance of real-time threat detection? And then we'll talk something about Kafka in IoT space, how this works on the architectural side. And then we'll take you to the IoT security challenges that is very common nowadays, as it's the IoT devices are keep growing. And what are the different models, machine learning we have or we can implement, and different ways that can be implemented to detect the threats in the real time. Then we'll showcase some detail about how the Kafka and machine learning works for the IoT security. And then we'll take you to the real-time threat detection in the IoT network. And then the last we'll discuss about if you have any question on the different scenarios, and so on. So this is for our QA session. Okay, so let's get started on the with the overview of Kafka and machine learning. So as you know that Kafka is a open source technology that came some time back, and that quite famous now for the real-time data streaming. So it's kind of queue system, or a system where it can be ingested data, and it can be uh, send the data to different sources. That is a real time. So it's a kind of replacement or the alternate option of different queue system like JMS or other queuing systems. But this works for a, like if you have a very huge data systems, or you if you have a data flow is very huge, then we prefer to go with Kafka for the data streaming. So along with the data, we have encountering a lot of challenges that require machine learning to detect the different problems into the stream. So to do this, we are using machine learning, and it's recommended to have these kinds of solution along with Kafka to identify the problems because of the data volumes. Okay, so this is just a brief about the Kafka and machine learning. I'm not going in depth about this topic, because as it's quite common nowadays, and lots of companies and industries it is already using it. So I'll take to the next challenge that we are going to discuss, like what is the need for the real-time threat detection. Because if I talk about why we need the threat detection, so and as I told you, like Kafka stream a lot of data that can be streamed from different sources. Like let's say for your database entry, if something is happening in your database, you are writing to the Kafka queues. So to make sure, okay, the data is uh, properly compliant and who is accessing the data. So this works in a event-driven architecture where the connection is not established, but you can send the data asynchronously to the Kafka and then from Kafka to different sources for different purpose. So as this is happening in the real time, there is a critical need for the real-time threat detection to identify who is actually publishing data to Kafka and whether this data is coming from the right source or not. These are the main challenges we are facing day to day. And so to resolve this, we have to build a solution to detect the threat in the real time. And to detect it, we have to identify the problem, mitigate the security risk. And then if I have to talk about the IoT system with the Kafka, it's also required to be secured the IoT ecosystem along with the data, because this holds very sensitive information of the users or the about the devices. So we'll discuss in more detail in the coming slides. Okay, so I'll take to the next slide here. Okay, so I'll talk about something about the architectural inside of Kafka in IoT. So Kafka actually plays a very vital role in the IoT space where, if I talk about IoT, it's kind of connected devices that sends data to the internet. So it is kind of sending data from your smart home, from your smart car, or from your telematics data to the Kafka, and from Kafka it can be generate different kinds of analytics. So this is important, like what is the role of Kafka in data processing, how the data processing works. Then we have integration challenges that we are keep facing day to day on the integrating the Kafka with the IoT or IoT with Kafka. So both the way it works. What are the scalability and performance consideration we have to take care, because this everything is happening in real time. So the latency between the data generated and then process the data for the threads and everything is very minimal. So we have to make sure the data processing and uh, we are getting the data at the right time without any delay to detect the actual problems. So I'll talk something about the IoT, what it is and why we need it IoT, and why it's keep growing it. So IoT is like a interconnected device, an object collecting and exchanging data. And like it's used at the present time, it is used in a lot of industries and different like automated cars. Then we have a smart homes like wind energy. Then we have industries. So you can see the adoption of like how the IoTs keep getting surge into huge cases, like like 10 million devices saying, like as per the data reports, adding every day to the network. Like a lot of users are keep growing it, and you can see that in critical infra 177% increase, smart building increased to 20%, and retail also acquiring a lot of IoTs to do the CCTV monitoring and so on, different use cases for theft analysis, and like a different use cases are there. So we have in the government also, where we have utilizing the IoT devices and the features of the IoT. And we have in healthcare, where we are monitoring the life-saving machines in the healthcare sector that is also connected with the internet and sending the data to the system to analyze and to recommend best, like to come up with the best solution. Banking also are introducing a lot of IoT things. Also, like these are the big sectors, but in the smart homes this is very quite common nowadays, where you have seen some smart locks that is also connected with the internet. And like these are the very low level use cases, but it's getting a lot of search due to the secured way and the growing things. Like in the home, we are using the CCTV's camera that is also connected with the internet to identify the thefts happening in the house. So all these things required IoT to be connected with internet and sending the data to different system to analyze and send back the response to the user in a real time. So these are the some of the use cases, but it's keep increasing day to day. So it will, like I can already told you, like it will collect the data, automate the process, interact with the other devices. These are the common use cases for the IoT. So as we can see that it's keep increasing, so there is a lot of security challenges that we are facing in the day-to-day activity, like how the IoT security challenges, what are the security challenges we have in the IoT network. So these are some of the security challenges we outline, like integration with the different protocol. Because this is not like a software, this is connecting with the hardware. So hardware connection require different protocols, RTMP, like different kinds of data transfer happening. All the data going from device to the servers for the analysis purpose. So, like connects how the integration will work, how the authentication and authorization works. Like your devices is connected with the system, so it should not be somebody else going and penetrate the network and put it their data to the network. So this kinds of encryption we have to do with the help of data encryption. Network security is important, like how secure your network is when you are transferring your data from your device IoT to your server. So these are very important. What is the scalability and performance metrics that we have to apply when we are facing a security challenges on the IoT? What kind of measures we have to do to secure it? And then the broker and cluster security. So we are connected with a network. So these are also part of it, where we have to secure the network with SSL and different things. Then we have to implement some way where we can do the real-time monitoring and anomaly detection to identify if there is any problem with the data, or if the data is getting manipulated by external things. So that also we have to monitor in the real time. Also, there is a regulatory and compliance requirement always there when we have to identify the problems and update as per the compliance and the government body of the specific country. So these are the security challenges of the IoT network when we are sending the data, or when it is staying, like how we can secure it, devices. So to address these challenges, like I have showed you a lot of security issues that we have, then now we have to get some solution how to address those security challenges. So I pointed out not all, but some of the basic or the very important ways that we can implement the securing the IoT devices and when transferring the data to the network. Like we should have a strong authentication and encryption mechanism where we have to make sure our data is secured and going through a secure channel when we are transferring the data. Then the next is like we have to keep uh, assessing the security changes and adding the more patches to the IoT devices. And these are the main things. And then we have to do real-time monitoring and the response to the user. So real-time monitoring here is whenever we are sending the data should not go and stay in the server, but we have to have a solution where we can monitor the data in the real time using different solution that will generate the report and send back to the user if there is any problem. I can give you one example, a small example, like you have a CCTV in your house that is connected with the internet, and you are having some theft, like you feel like there may be a theft going to happen. So how the theft can be detected using the IoT. So these kinds of anomalies can be generated based on different models or machine learning algorithm you have supplied to the system. So it will detect the theft with the some movement of the hand or what you are doing in front of the house, lots of other things. So next is the network segmentation and firewall. So whenever we are doing any kind of transfer or anything, it's important to have firewall security the at the network level to make it secure data transfer from IoT to the system. So the next one, I will just take you to the machine learning. So machine learning is quite common nowadays because of Chat GPT, and lot of different things are coming with the deep learning models. It is actually little easier now to develop your own model, detect the anomalies, and adopt the security measures. So it's kind of keep learning things, and you are keep getting the data from IoT devices. So the data is not a problem here because you are already generating the data from the devices. You just have to build your model in a way that it can be detect the threats in the real time without any delay, and to intimate the users at the right time. So yeah, so this is the like I'll not talk more about the machine learning here, but yes, machine learning is like you have to build model, you have to train the model, you have to create the model, and then apply those model onto your data so that it will give you some real-time analytics and update on the security. So I'll take to the next slide. So now next is like how the integration will work between Kafka and machine learning and with the IoT. So we are keeping the IoT as our main source of data that will be keep getting coming to us, and how we can ingest the data, how we'll train the model, and how the detection will work. Yeah, so now I'll take you to the case study what we have, like how the description of IoT environment, how the implementation of Kafka works along with the machine learning, and what are the result and impact on the security, like how we can generate it. So here there is a one slide on the GDPR. So this example I have taken to showcase how the Kafka works along with the machine learning, and how the ecosystem works. So this is from a real-time use case that we have done. So here there is a user. You can see that user log into the application. So the application is required to fetch different data from different sources. So the user is, let's say, like trying to get some data from the, like exporting some data, export data as PDA, PPT, or Excel, then generate historical report. So all these things have some activity onto the database, or wherever you store your repository, wherever you store your document or the repository. So all these things require to be monitored by the company or the organization to make sure the user is the right person to access those data. So whenever you do any kind of changes or any kind of fetch on the database, we are creating a trigger on our Kafka topic, just to make sure that the we are having the track of the data, what's happening. So whenever there is any call happen on the database, the Kafka will get access to of those data, and then it will send to the GDPR microservice. So we have made a custom microservice here that will be store the object ID, object name, object type, user ID, timestamp. So this is a kind of CDC solution. And when we go to the Kafka, we have also fraud transaction uh, detection in the real time. So what is happening whenever you access, we have to make sure that the whoever accessing those data, the user, is authorized and the user is the actual user of the system to access those data. And so we have used here KSQL. So KSQL is from Confluent that is very powerful in doing the real-time threat detection. When we fetch any data from the system, it will store as a SQL format, and we have to query define the user-defined function, and that will detect the anomalies, and this will again go to Kafka, and from Kafka we can trigger to the user about the like data protection team, like okay, the data accessed by the user is not the data the user should access, or the user is not the right user who can access those data. So all these things we have done in a real time. You can see that here the Kafka, from Kafka it is coming to the KSQL. So in the KSQL we have user defined function, and then we are doing the real time threat detection, and then notifying the data protection team if there is any fraud user or if any unauthorized things happening in the real time. So it will be a trigger based on like if any unauthorized data access notification, it will send like you can implement all push notification or whatever you require, but it will intimate to the team to look into the system. Also, you can see that because of Kafka, everything is connected in a asynchronous way, because this is not a synchronous where we are stopping the user directly, but it will keep generating the data to Kafka and keep analyzing the data and doing the immediate response to the protection team if there is any issue in the data or the access, unauthorized access. And also we are keeping everything in our database for the further analysis or for the analytics purpose. If you have Kibana or Elasticsearch, you can do it. So next thing is I want to talk little bit more about Kafka and how the Kafka works and why we need the SSL client authentication. See, Kafka works in like consumer broker mode where we have consumer, producer, brokers, and uh, a segment. So you can run Kafka without SSL. That will be plain one that you can directly connect and fetch the data. But this is not the right approach. So we are proposing the client, and when we do the implementation, we should go with the Kafka with the multi-tenancy architecture to control consumer of the data, like who can access those data at the from the Kafka system, like how the brokers can be secured, how the topic can be secured, how the access will work. So all these things we are doing with the Kafka SSL client authentication. You can see that we are issuing certificate also for the client who are the actual consumer of the message. So you can see that non-secure topic. So it can be accessed easily without much problem. And we have secure topic also, where a consumer can access only with the right certificate. So to access the topic or to consume the messages from the topic, you should be a proper access. Like without access or without proper certificate, you cannot access the data from the secure topic. But this is not the case with the non-secure topic. So the producer also generates certificate, uh, and this can be published to the topic, and the secured way the consumer will read it. So this is kind of multi-tenancy architecture for the Kafka SSL security. So you can see that without authentication, both consumers are consuming the records. And then we have only server-side authentication, customer records only for matching server-side certificate. So this is the way this whole architecture work, and that is very important to have the our Kafka secured with the multi-tenancy architecture. for the safety of the data. As we are sending the data from IoT or maybe different sources, it should be secured. So this is how the technical works of the Kafka SSL security. So we'll take to the next topic. Like this is for the real-time detection of anomaly from IoT. So anomalies in IoT is very common, I can say, because we have some example I have given here, like connected car infrastructure, smart cities, a smart home, a smart retail, customer 360, intelligent manufacturing. Then we have other use cases like in the wind energy, in the power grid system. So everywhere the IoT system is sending the data to the server for the real-time threat detection. So this is like a day-to-day, like keep increasing, and the transaction volume is very, very high, and that is also very, very critical for any country or any industry to make sure their power grids are secured when we are talking about IoT, because all the data transferring about how much power producing and everything, all the details, what is the speed of the wind, or what is the megawatt or whatever it's producing. For the retail also, like I can give one example. In the retail, a lot of thefts happening in the retail stores, and there is challenge for the companies how you can do the theft analysis in the real time. Like if there is a potential of going to be stolen something, some goods, or from your home, or this for your car also. Let's say for your car, you are driving your car at the speed of 200, but your engine is going much higher temperature. So all these things you can do in the real time and instruct the user that your car is getting heat up and you have to reduce the speed, or some intelligence parameter using intelligence suggestion to the driver. So these are some of the IoT devices connected with the MQTT. So here the MQTT is important when we talk about the Kafka. So Kafka cannot directly connected with the IoT devices without the help of MQTT. So MQTT here is a broker that plays an important role in connecting the IoT devices with the Kafka. So we have used MQTT Kafka connector, that is from Confluent, to do the connection between Kafka and MQTT. So this is an inbuilt solution that you can use it to connect with Kafka and MQTT and send the data from MQTT to Kafka. So here you can see one diagram is there. This is actually KSQL diagram where we are having the KSQL also here just to do the real-time threat detection. And then from the Kafka, we are sending our data to Elasticsearch, Kibana, and to the user. Like here, let's say a lot of data getting generated. The data should be in a raw format. So we have to parse the data, modify the data, and make the data in a way that it can be produced to the business user or the user who is working on analyzing the data in a graph format and different way. And the user can be send alert if they find any anomaly. So this is kind of user doing it, but we can do it with the automated way also using the machine learning and the KSQL that we have showed here. And then again, we have another MQTT connector, MQTT, that will send back the data again. If there is any alert, that will be triggered and sent back to the IoT devices or the user. Like, okay, there is some issues with the data, please look into that. So from the multiple IoT devices, this is a business case, like how the whole things works. So we'll take to the deeper dive on how the actual technical things works for that, like how the detection works in the real time and so on. Okay, so this is our technical view of the detection of anomalies from the IoT. So here we have just given some in-depth detail about how the whole architecture works and what we should do to uh, what we should do to secure your devices and how the whole thing works here. So the devices is connected with the MQTT broker, that is PubSub model. It's like it will produce all the telematics data or the smart home data or CCTV feed to the broker, and the broker will send to the Kafka Connect. So the Kafka Connect will again so there is a two Kafka Connect. You can see that one is source and one is sink. The source is actually like how the data will go from MQTT to Kafka. Sync is once we analyze the data, how we'll send back the data back to the device or to the user. And then we have the core is the Kafka. And then from the Kafka, we are sending the data to KSQL. That is a kind of database for the Kafka messages. And there we have user-defined function. So the user-defined function is like how you are defining your function for the detecting the problems. And then we have deep learning algorithm. So here we have the machine learning part and like how the you have built the algorithm to detect the problem. Let's say you have I'm giving you other than the IoT, like let's say for the banking fraud, this is quite common to use this architecture where uh, you are encountering a user is trying to log in with the fabricated password and the user and trying to get access to the some transaction or some system. So this will be recorded into KSQL, and the deep learning algorithm will suggest you about what's problem with the data and how you can mitigate it or alert the system. Like it will not resolve it, but yes, it will alert you to the problems and you can quickly act on the problem. So you can see that once Kafka, it is going to KSQL, then deep learning, and then if there is any anomaly detected with a new stream, it will send an alert to the user. And also we have Kafka Connect Sync connector that is actually sending the data back to your database, different microservices for different purpose. So this whole thing works like that, and this everything is happening in a few seconds only. Like there is no much delay, like because this connected asynchronously and the data processing happening in the real time. So you will get the response in very few, like a millisecond. Also, we can say sometime you will get the response that okay, there is some issue with the data, or you should look into that. There is some problem going on with your system. So as we already told about, like it's the network is keep growing and we are keep adding new system to the IoT, and lot of algorithms are keep building it, and different use cases for different scenarios we are facing. And this is the field where the lot of study is still going on, and lot of different new ideas are keep coming up to do the real time anomaly detection. So yeah, I think I have completed all my topic of discussion today. So if you have any question, please feel free to ask.
It is. All right. Then thank you so much, Rahul, for your presentations. It's really interesting topic, especially nowadays with a lot of IoT adoption, especially in many sectors as well, and also the increasing adoption of AI and machine learning. Certainly, cybersecurity is a really big topic for that application for it. So I think we can then stop the recording. recording. Now. And yeah, so if you have any questions, you can click the button of raise hands, or you can put the questions in the chat if there is